In this video, we'll be taking up the homework sheet on developing equation of a quadratic relation. So the first question, they give us the vertex and a point, so I build the equation in vertex form. In the second question, they give us the x-intercepts and a point, so with the x-intercepts, I know the zeros, and with the zeros, I can build the factors. And then solve for the factors and sub in the point, then I can build the equation in factor form. And for question 3, I'm given one of the x-intercepts and the axis symmetry. So using the idea of averaging, I can solve for the other x-intercept. So 2 and another number averages to 3. So just basically solve this equation and you see that the other x-intercept must be 4. Now you can also visualize it based on this diagram. It makes sense that the other x-intercept is at 4 as well. Once you have the x-intercept, sub in the y-intercept, and you can solve for a, which will give you the equation of the quadratic relation. For question 4, I am basically told the vertex because they told me the optimal value and the axis symmetry. Sub in the point, which is the y-intercept, and solve for a. Once I have a, I can write the equation. For question 5, I'm told that the parabola is congruent to this other parabola. Well, if the shapes of the two parabolas are congruent, what they're really saying is the vertical stretch factor, or vertical compression factor, are the same. So once I have a, and I have h, and I sub in the point, then I can actually solve for k. For question 6, you have 3 points, one of them being the y-intercept. So because you know the y-intercept, you can say C is the y-intercept. Now if you didn't know that fact, just sub in the point 0, -1, and you realize C is -1. Sub in the other 2 points, and then you build a linear system in terms of A and B. Solve it using elimination and substitution. For questions 7 and 8, it's really the same 2 questions that we did in the homework lesson, or in the handout. So one was the toy rocket, and the other one was the tunnel. So for the tunnel question, you can build an equation that looks different from mine, but it can still model the tunnel correctly, and we can tell that it models it correctly as long as we both get an answer of 16.8 meters.